Hutchinson. So Dr. Hutchinson, thank you for joining us. We appreciate you taking the time to speak to us tonight. Before I ask Terry to introduce you, I'd like to take this opportunity to tell you all how glad we are to have you join us. Also, I'd like to mention that we hope to be able to continue to provide these educational opportunities about environmental and climate change matters. And in order to do that, it helps for you to be a member of our organization. And if you're able, we'd appreciate a small donation to help cover our expenses. You can do that by going to our website, www.environmenthaliburton.org, and go to the members and donations page. Thank you so much. And now I'd like to ask Terry Moore, our Vice President, to introduce Dr. Hutchinson. Over to you, Terry.
Thanks, Susan. Before I actually do that, introduce Dr. Neil Hutchinson, I just want to say a couple of things about tonight. The first one has to do with the question and answer period that'll follow immediately after Neil speaks. And secondly, I'd just like to say a couple of things about why we've chosen to focus on the topic we have tonight. First, on the Q&A process, we would like you to put any comments or questions you have about any aspect of Neil's presentation into the chat box function that you can access at the bottom of your screen. At least I think it's at the bottom of your screen. It's certainly at the bottom of mine. After Neil has completed his presentation, we have arranged for two first commenters to lead off the Q&A period, and that's Jackie Hart from the Friends of the Muskoka Watershed and Jim Prince from the Conesus Lake Association, both of whom I'll properly introduce later. While Neil's speaking, I'll be monitoring the comments and questions, and after the key commenters have had a chance to make one comment and put a question each, I'll then start working my way through what you have placed into the chat box. I may put some questions on the same theme together if they cover similar or a related topic. Now, about tonight's topic, it's certainly no secret that development pressure on Haliburton shorelines has been increasing in recent years, and the pandemic and related restrictions on vacation travel has turned that trend into a virtual frenzy. This real estate boom on the waterfront has accelerated the conversion of seasonal legacy cottages into larger year-round permanent residences, and a parallel trend has intensified the use of shoreline cottages and homes for new commercial purposes, enabled by some of the online platforms such as Airbnb and Vacation by Owner. This in turn has resulted in escalating tensions on the waterfront over a wide range of issues, from noise pollution, including the pervasive use of fireworks, to increased boat traffic and the ubiquitous presence of personal watercraft, to conflicts over wake damage and the overloading of septic systems, just to mention a few. This development and real estate boom is happening at a time of rising concerns over lake water quality, declining levels of natural shoreline vegetation, and climate change with its associated increase in air and water temperatures, blue-green algae blooms, extreme weather events, insect and disease infestations, and biodiversity loss. These tensions have increased the pressure on local municipalities to assume a larger regulatory role, at the same time as decades of austerity-driven budgets and downloading of responsibility from senior levels of government have severely stretched their capacity to do so. How can municipalities manage the rising pressure from intensified shoreline development? Are there ways to control development pressure in order to minimize the kinds of conflicts we're experiencing while protecting the health of our lakes at the same time? Can municipalities play a meaningful role in protecting lake health and shorelines in the face of reduced presence and capacity by provincial agencies such as the Ministry of the Environment and the Ministry of Natural Resources? Those are some of the questions that have caused us to want to focus on this topic tonight. Dr. Neil Hutchinson, in the process of retiring owner, I suppose I should put it that way, of Hutchinson Environmental Sciences Limited, an environmental consultancy firm in Bracebridge. And he's well placed to help us think through some of the questions that we posed, such as the above. Neil worked on something called the Lakeshore Capacity Assessment Project for the Ministry of the Environment from 1988 to 1998, a project that was focused on providing municipalities with tools to address, at least some tools to address, shoreline development pressure. Neil's professional career has focused on pollutants and stressors of aquatic systems, extending from the laboratory to whole watershed levels of investigation and specialization in the Precambrian shield systems we have right here in Muskoka and Haliburton. Neil lives on the shore of a small lake outside of Bracebridge in a home he shares with his wife, Barbara, 3 daughters, a dog, and too many black flies, he says, in June. He chairs the Science Committee of the Georgian Bay Forever, the Science Committee of Georgian Bay Forever, serves on the board of the Friends of the Muskoka Watershed, and is a member of the Muskoka Watershed Council. Please join me in extending a warm Haliburton virtual welcome to Dr. Neil Hutchinson. Over to you, Neil.
Thank you very much, Terry. It's nice to be returning to Haliburton. I spent my first 5 years in this part of the world living in Carnarvon, and it's fond memories, but I got married and came to Bracebridge. I'm just trying to get my whole screen up. There we go. So tonight's talk is we've talked a lot about the need for managing shoreline development pressure and the emergence in Haliburton, that it's something that's based on protecting the shoreline. And that's kind of a transition from what the past 30 years have seen, which has been a focus on capacity, which is how much development is acceptable. How do you determine that? And is it an effective way to manage shorelines? So what we're trying to avoid, of course, is this lovely COVID party on the shore of maybe we'll say Kinesis Lake or Boshkong Lake, where I used to live. We don't want to see it develop to this. So we're going to try to talk about some of the methods that have been used to manage the capacity and the amount of development on the lake. There are many other capable people who can talk about specific aspects of shoreline protection and vegetation planting and management and wildlife habitat, and lots of really great tools that can be accessed through the Federation of Ontario Cottagers Associations, through conservation authorities, and through the Muskoka Water Web, which is run by the Muskoka Watershed Council. So there's lots of tools out there that we can use. I'm going to walk us through the capacity part of it. So the first thing you want to really ask yourself is why do you want to manage lakes? Why do you want to plan for lake development? Why would you want to set development capacities? Why would you want to manage the process? Can't we just have a free-for-all and let it rip? I've always seen it as a matter of perspective, and this ancient Far Side cartoon really kind of puts it around and wonders what would happen if it was the fish that were building condominiums beside our lakes, and we were having to worry about how many fish condominiums we could have before our beach towel was shaded out. Or even worse, if these fish condominiums were Airbnbs, where there's way too many goldfish in each bowl, which I gather is an increasing problem in our part of the world. And I say our, including Muskoka and Haliburton. What are we really trying to manage here? Are we trying to manage water quality? If we could solve a water quality problem, would there be something else that we'd want to manage? Social crowding. How many people does it feel comfortable? Are we trying to experience a wilderness experience on our lakes, a perception of nature? Or are we trying to have a boating free-for-all or a bass derby? What is it we're trying to accommodate? What are the uses that different people make of our lakes? What is the impact of management on a local economy, and how important are lakes to our local economy? Certainly in Haliburton and Muskoka, they are very, very important, but they're driven by good water quality and a nice environmental aesthetic that people want to preserve. Are we trying to manage ecological attributes? We always want to hear the loons calling. We always want to be able to catch a fish, a healthy fish off our dock. Are we trying to manage boating density or the intrusion of different types of activities? Jet skis are frequently mentioned. We're in the big lakes in Muskoka. We now have the wonderful cigarette racers, very, very loud 90-mile-an-hour boats that roar around. So what are we trying to manage? And does that determine the approach that we can use? Or can we find an approach that meets several goals or all goals? We have to remember that both municipal planners and people like stability. This is a message that was given to me by the CAO of the District of Muskoka 20 years ago. People want stability. They want to know what they can expect from one year to the next. And even change can be stable as long as it's gradual, but you have to watch for that. But people want to come to cottage country. We want a stable ecological environment. We want our water quality. to remain good. We want to prevent observable aesthetic changes. And in cottage country and recreation, that tends to be reflected in the growth of algae, its effect on water clarity, whether or not we get nuisance blooms of algae in our lakes. We also want water quality that's sufficient to protect aquatic life. Can we manage the lake trout habitat from the impacts of too much development and the consumption of oxygen in the cold bottom waters that the lake trout prefer? Can we protect the nearshore habitat, the spawning, the sheltering, the feeding areas that are so important to fish and aquatic life and important to amphibians and loons for feeding? That's what we're talking about for shoreline protection, where those come in. And then there's also shoreline wildlife and waterfowl habitat, maintaining our wetlands, maintaining access, the interface between the nearshore zone and the onshore zone. So people want a stable ecological environment as a management goal. People want a stable social and aesthetic environment. We want to be able to protect a variety of recreational opportunities. We want to buffer different uses so that they're not interfering with each other. And people want to come to know what they're going to expect when they come up to the cottage for the weekend or when they live there year round. We also have to recognize the need for a stable economic environment. We have to protect the property values from degradation. Not a problem these days, the way they're accelerating across the province. And we also want to maintain employment opportunities because people who live here year round want to have good work to do. And in the cottage country, that's probably going to involve building things. There's kind of two general approaches one can use for lake management. One is an approach of lake capacity, which involves setting the limit to the amount of development on a lake to protect specific attributes. In Ontario, that's been a sole focus on water quality, and especially the aquatic plant nutrient phosphorus has been the focus in Ontario for 30 years. Another way to do it is to set best management practices, where you don't set limits, but you set rules to minimize or mitigate the impacts. It's another way of saying one bad apple can spoil the whole barrel. You can have a lake that's jam-packed with people, but if everybody's behaving themselves and respecting each other, you don't have many conflicts. Or you can have a lake that's not very crowded and one or two bad actors that can generate a lot of conflicts. So how do you set rules to minimize or mitigate impacts? You can do it quite easily by setting the minimum lot size. That tends to limit the number of cottages and residences on a lake. You can insist on shoreline naturalization and not altering the shoreline. Or you can say, if you're going to put a septic system in, that you have to find a way to manage the phosphorus in that septic system so it doesn't get into the lake, or you don't put fertilizers on your lawn, or even better, you don't have lawns. The Lake Simcoe Protection Act, which was passed in 2010, is a good example of encouragement of best management practices. It's recognizing that there is huge social growth around Lake Simcoe and Barrie and Orillia and the East Shore, and that's not going to change. The government is not interested and can't really stop that sprawl, but they're trying to manage it the best they can by setting rules in place such that new developments have to have best available technologies for stormwater management, for sediment management, and for export of phosphorus nutrients, these type of things. And so recognizing that there's not going to be a capacity, but we'll try to manage the best we can by putting BMPs, or best management practices, low impact development techniques, into place. And then there's also hybrid approaches, a little bit of both, where you can use calculate capacities for a lake and classify a lake based on capacity, and then add planning standards. So a district of Muskoka, for example, pre-2005, used a strict capacity approach based on limits of phosphorus, trying to maintain the total phosphorus below 10 or 20 parts per billion micrograms per liter, which was the provincial standard at that time. And I'm going to explain how we do that in a couple of slides. But they also coupled that with planning standards, like a minimum lot size, enhanced setback for septic systems. The provincial standard was 20 meters between a septic system and the shoreline. Muskoka has for a long time maintained a 30-meter standard just to minimize any impacts associated with that. Or you can also classify lakes based on their sensitivity to desired uses. You can vary the capacity or the best management practice approach with classification. Between 2005 and 2019, the District of Muskoka used a lake sensitivity approach, where instead of setting numeric limits for development, lakes were classified into whether they're low, medium, or high sensitivity, with increasing severity, increasing scope of best management practices as lakes became more sensitive. At the same time, trying to maintain a total phosphorus concentration below something called background plus 50%. And I'll be talking about that shortly as well. But in Ontario, the approach to lake management in Ontario has always been to set development capacities based on water quality. This is fundamental work that was done in Haliburton and Muskoka through the Dorset Research Center, where I came to work in 1984. And it was science that came out of Muskoka, and particularly Dr. Peter Dillon. But this led to the Lakeshore Capacity approach, where you quantify human sources of nutrients, total phosphorus being the nutrient of concern, setting acceptable levels of nutrients, water quality objectives, and then setting development capacities to limit how much human nutrients you could put into the lake, thus maintaining your desired environmental status. So this is all came out of the Lakeshore Capacity Study, which is started in 1986. It was published in 1986, actually. It started in the late 70s. And the idea was, in typical 70s fashion, you'll see the graphic at the bottom, where there's this idea that if you could put all the right actions and models and numbers into a computer and twist a few knobs, you could get a magic output that would say, bingo, here's your answer. Here's your magic capacity number. It's kind of a black box model of acceptable limits to development on recreational lakes. It looked at microbiology, about the association between microbes and ear infections and swimmer's itch and such. It looked at land use. It looked at fisheries. It looked at wildlife and wildlife habitat. It looked at trophic status, and then tried to integrate them all together. The trophic status model, trophic status is another way of saying lake nutrients. We tend to appreciate the clear, low nutrient lakes. We call them oligotrophic, that characterize this part of the world on the shield. But you can have enriched lakes south of us, which are eutrophic, that is, have many nutrients in them. So that's called trophic status. And the model to predict that based on total phosphorus is the trophic status model. So it was implemented by the Ministry of the Environment. I started working on it in 1988. I left the ministry in 1998, and they finally got it accepted into policy in 2010. So it's a long time being developed. So what does it do? We model recreational water quality. The graph on the left shows on the y-axis going up Secchi depth. That's water clarity, where the higher the number at the top, the clearer the water. And then as you go down the y-axis, you get lower and lower water clarity. And across the x-axis is chlorophyll. Chlorophyll is the green pigment in grass and leaves and algae. So this is really telling us that the more algae you have in the lake, the less water clarity you're going to have. People prefer good water clarity over poor water clarity. The graph on the right shows that as total phosphorus increases in a lake, chlorophyll goes up. So total phosphorus can come in from natural sources and human sources. And unlike many pollutants, it's essential to life. We're not talking about something like DDT or mercury or dioxin, or the type of pollutants that are damaging in very, very low quantities. We would not have aquatic life. Phosphorus is the currency of energy in our own bodies. It's essential. So you add a little bit, you get quite an effect. But the trouble comes when you add too much. And the first thing you do is you add, you might generate an algal bloom, like we see on this picture, and you'll decrease your water clarity. And if you add too much, the algae dies, decomposes, and sinks to the bottom of the lake in the summertime, where microbes chew it up and suck oxygen out of the water, which has a problem for lake trout, which are confined to that depth. So the Ontario Lakeshore Capacity Trophic Status Model is a phosphorus model. What does it do? Well, we start at the upper right. It looks at natural sources. Atmospheric deposition, dust, rain bring phosphorus into our lakes. Watersheds bring phosphorus into our lakes from a basis of geology and the number of wetlands in the catchment, and also influenced by land use. You put these together and you can have a natural or a background concentration of phosphorus. It's hard to measure a background concentration of phosphorus because all of our lakes are developed at this point. So we have to kind of tease it out using modeling techniques like this. We then go over to the left in the yellow, where there's a shoreline development on the lake. And you make assumptions, you count the number of septic systems, you make assumptions about how many people are in the cottage and how often they use it. And you calculate urban runoff from people that have cut the trees down and opened up the lots. And you then get anthropogenic phosphorus, the human phosphorus that goes into the lake. You put both of those together and you can get the total phosphorus in the lake, whereas the provincial objective for Precambrian shield lakes as of 2010 was background, which is the blue, plus a 50% increase. That's what the objective is. And you add a knowledge of hydrology, how much water moves through the lake in a year, and the shape of the lake, and you add that to the loadings, and that gives you a total phosphorus concentration. And then the provincial standard is background plus 50%. Now, 5 minutes ago, I talked about before 2005, we had an objective of 10 or 20 parts per billion. We moved away from that because that would, over time, all lakes would converge and be just below 10 or just below 20. You really have two sets of lakes. Background plus 50% said that a lake that started out at 4 parts per billion, like many of our nice lakes did, maybe the Halls Lake, would increase as much as 6. And if they started at 8, they could increase to 12. And so you ended up with a much more diverse population of lakes and maintaining the range of lake nutrients that you'd always had. So that was the basis of the background plus 50% objective. You can then use that as a regression line I showed you on the previous slide to predict chlorophyll A or water clarity, or you can dump your phosphorus and your chlorophyll into a model of lake morphometry and predict hypolimnetic or deep water oxygen. So all of these have various coefficients and measurements associated with them, all of which are really specific to Halliburton and Muskoka. So what we do on the Lakeshore Capacity approach was to manage phosphorus loading by modeling the lake response to development, comparing the current lake status to a water quality objective of background plus 50%, and don't forget to compare it against the measured values just to make sure your model's working. Setting nutrient limits really based on how much loading is coming in from the septic systems and how much will keep you below background plus 50%. And then the plan is that you would enforce these development capacities in the official plan. If the model said you could only have 128 cottages on a lake, then that would become your official plan capacity. It's a regulated limit to the number of shoreline septic systems, hence a development limit, what I call planning by plumbing. That is, you're limiting managing the capacity of the lake and the number of the people of the lake based on the plumbing, based on the number of septic systems and your assumptions of how they work. It does not address social crowding. It does not address boating. It does not address fishing. It does not address wilderness aesthetics. It simply addresses the plumbing around the place. So you could also see that if you had better plumbing, better septic systems, this would not be as effective approach for safeguarding some other things. So how would this work? So here's a collection of 30 some odd lakes. And the black bars, they're not arranged in any particular order except from low phosphorus, which is the y-axis. On the left, the high phosphorus on the right. And these are in a watershed of Lake Vernon, north of Huntsville. And the black bars are the calculated background concentration in each of those lakes. The white bars are the objective, how much you can increase the phosphorus concentration in those lakes. So at the left, you don't increase it very much. At the right, you can increase it quite a bit, and you maintain a diversity of lake types. And then you translate that based on how the lake processes phosphorus, its hydrodynamics, and how much phosphorus comes in from loading from septic systems, et cetera. And now we have a y-axis where we translated that capacity into the number of cottages that these lakes could support and maintain background plus 50%. And you can see that the lakes are still arranged in the same order from left to right, but because different lakes have different flushing rates and different sizes, they have quite vastly different development capacities based on phosphorus. Some of them you can have 8 or 9 or 10 cottages, some of them you can have 500 cottages. It does not answer if there's room around the shoreline for that number of cottages. This is just based on phosphorus. So this is how capacity has worked and how it's promoted by the province as of 2010 and even before that. Whereas you do this model, you conclude that 124 cottages is acceptable, 125 cottages would therefore be over capacity, and that was what you would defend in your official plan. And ultimately, some developer would come along and want to add 3 cottages and sever off some lots, and if you're over capacity, you usually end up at the municipal board arguing about whether this is a good idea or not. The question I have is, does the model and the approach support this level of precision? Can we really distinguish the water quality impacts of 124 cottages from 125? We certainly couldn't view it with our eyes as water clarity. So there's several things to consider. We all live in a watershed. Watersheds are complex. There are lots and lots of different lakes to consider, and they all have to be linked together, because what you put into a lake at the top of the watershed will influence the water quality downstream. Muskoka watershed model has 525 modeled lakes or lake segments in 17 sub-watersheds of different sizes, some of which, all of which drain to Georgian Bay, except for some that drain south. The model itself contains uncertainty or variance. There's not too many certain things in this life. The way to take all the loadings and predict the phosphorus concentration in the lake is a locally specific relationship, which was developed for lakes near Dorset by the Ministry of the Environment. Things like atmospheric deposition, input from watershed, and the natural phosphorus load are measurable, and they're locally specific, but they change as the data changes. As we learn more about geology, land use, and atmospheric deposition, those numbers can change, and they will change the estimated natural background concentration. Things like shoreline development and anthropogenic phosphorus load are really uncertain information. One of my big surprises was the whole point of this exercise is to manage how many cottages you can put on a lake. And you could go ask a municipality, how many cottages are on the shore of Boshkong Lake? And they say, well, I don't really know. And how close does it have to be before it counts as a cottage? And is it occupied seasonally or more than seasonally or year round? Those are uncertain numbers. I live on a small lake where there are 4 permanent residences, and 1 seasonal residence, and yet the Muskoka planning document said there was 8 residences on that lake. So it surprised me that something that was supposed to be so precise is not always supported by good data. So there are uncertain elements in this approach. And what does this mean? Is the model accurate? Well, this is the Muskoka model as of 2016, the last time we looked at it. The graph on the left, you'll see a straight line. If all the black dots fell on that solid straight line, the model would be perfect. We have the measured phosphorus in the bottom and the modeled phosphorus on the y-axis. If anything is within the 2 dotted lines, that's plus or minus 20%, and that is the acceptable error that the Ministry of the Environment allows for their model. If you look at the table below, the average error is 52% too high or 25% too low, and more than 64 lakes have more than a 40% error. If we look at the upper right, here is the lakes that don't have much development on them. Background plus 10% is what we'd interpret that right-hand graph as, and it shows plus or minus accuracy above the 0 line. So not very good. If we go down and look at all of the lakes, and we look at lakes across the bottom, as development increases, the error increases. So the more you assume about the development on the lake, the more you overpredict the phosphorus in that lake. So it doesn't give you a lot of faith in trying to defend 124 cottages versus 125. So why isn't the model accurate? Well, the Lakeshore Capacity approach assumes that phosphorus is mobile. It assumes that all phosphorus moves from the septic systems to the lake, everything within 300 meters, according to provincial guidance. One of the MOE's study lakes up near Huntsville was Harp Lake, probably the most studied lake in the country. 74% of the assumed development of phosphorus from that lake could not be accounted for in the phosphorus budget for the lake. It was likely tied up in catchment soils. And that was back in about 1994. In 1998, the Ministry of the Environment started providing research funds to Professor Will Robertson from the University of Waterloo, who was up here looking at nitrate in septic systems, and he was asked to look at phosphorus as well. And he published his first paper on the subject in 1998 and found that the phosphorus in septic tanks is immobilized by adsorption onto soil particles and reacts with aluminum and iron in the soil to form permanent minerals. It was often retained within half a meter of the tile fields, even after decades of use. That kind of throws a little bit of doubt into the model. He culminated this research. He's retired now in November of 2019 with a review of 24 septic systems that he'd looked at. And you can see they're located here on the right-hand side, all of these up above the on the Canadian Shield, so they're quite representative of what we have, but he also looked at ones off the Shield to the south and some down by Lake Erie. The arrow points on the section of the abstract that says, phosphorus removal in the drain fields averaged 90% where sediments were non-calcareous. That's Canadian Shield sediments, no calcium. And 66% at sites where sediments had calcium in them. Now that's, if you go back up the diagram, you can see here it says drain field effluent input. You can see a cross section of a septic system in what's called the accumulation zone. So he's saying here in the Canadian Shield, 90% of the phosphorus from decades can be accounted for right underneath the tiles. If you then move into the proximal zone, which is the next segment of the plume moving away from the septic system, he could account for 97% of the phosphorus that had ever been added to that septic tank that was immobilized by the soils. Very, very consistent results, and really puts a lot of, removes a lot of faith in these assumptions. Another example of what development has done is this work from 1998, I think it was published in 2000 by Salome Clark from Queen's University and her colleagues. And this is Peninsula Lake and Fairy and Peninsula Lakes. They did it for both. And they used the technique of paleolimnology, which is worth a lecture in itself. It's fascinating stuff. I'm a paleo enthusiast, even though I don't do it. But they are reconstructing the environmental history of the lake from what has been preserved in the sediments, from the remains of algae called diatoms, from the remains of head capsules of biting midges. And they can relate these to the environmental history of the lake. So we can get background by using our model, or you can get background by using a paleolimnological method. So Fairy Lake, Peninsula Lakes, are right adjacent to Huntsville, very heavily developed, and they were quite stable between 1700 and about 1850, 1830, when we started building railroads up to this part of the world and cutting down all the trees. And the phosphorus started creeping up. We cut down the trees, we settled the land, we built our farms, and phosphorus increased from about 7 up to about 12 micrograms in those lakes. And then it kind of stabilized. And around about 1950, or actually post-war, is when the real boom in shoreline development happened in Ontario. People had enough money and they were coming north to go to build their own cottages. And this whole period of increased shoreline development between 1960 and 2000, phosphorus concentrations declined in the lakes. So there's several things going on. There could be an acid rain signal here. It was quite likely the forest growing back and removing the agriculture, agricultural lands converted to cottage lands, but the phosphorus dropped, where the Lakeshore Capacity model said, well, it should have been increasing. Well, what's happened since then? Here's the District of Muskoka data. The red lines at the top of each graph show the phosphorus concentrations in each basin. And from 1990 up to 2018, phosphorus is highly variable, but if anything, there's a bit of a downward trend in the West Basin and not much of a trend at all in the East Basin. So we can't say that development has had a huge impact on these lakes in terms of septic systems. So the problem, as I see it, is that Lakeshore Capacity assumes there's a finite limit. It assumes that there's a line in the sand, and this line in the sand is my 124 cottage example. In reality, it's really a broad ribbon in the sand. It means that as phosphorus goes up in a lake, you have to be concerned about it, but there's no one point where you can say with any accuracy that you know how much phosphorus is in the lake or you know how much should be in the lake. I kind of make an analogy to a speed limit here. The speed limit may be 80 on Highway 118. If I'm going 82, that doesn't mean I'm in trouble. But if I keep going faster and faster and faster, at some point I will get into trouble. So, but 80 is a bit arbitrary, but it's set to try to keep people safe. And the policeman never believes me when I say I was still safe at 90, and he gives me a ticket anyways. But background plus 50% is really more of a trigger for management, and I would not recommend it anymore as an absolute threshold for capacity. Ontario use it as a capacity determinant. Environment Canada have a phosphorus management framework for the whole country, and they just use, once you hit 50%, you start looking into causes to see if it actually is a problem, and if so, what you can do about it. So the problem is that the model is not accurate enough to defend. The basic assumption of septic phosphorus mobility is not supported by investigation. The history of development impacts on water quality is not substantiated in water quality records, either from the district's measured concentrations, which in District of Muskoka, in the 200 some odd lakes that are monitored, water quality is stable or phosphorus is declining. There are no lakes in Muskoka where phosphorus is increasing. And we saw in Peninsula Lake from Salome Clark's work, and also Muskoka Lakes in general, Dr. Roland Hall did some work there in 1996, and also showed there was no strong development signal. So this leaves a problem then. If you can't support management and capacity limit in the number of people by phosphorus, what are you left with? You've put all your eggs into one basket, and you thought that was going to solve your problem for you. Well, it's apparent that you can't. So in Muskoka, we've seen evolution of away from this approach over time. Pre-2005, there's a strict capacity based on total phosphorus and the existing water quality objectives of 10 or 20. Between 2005 and 2019, we switched to a sensitivity-based assessment and best management practices, acknowledging that capacity was not really the big figure here. Lake sensitivity was probably more defensible. We still had lakes that were highly sensitive and were over background plus 50%, they would have the highest level of protection. But we implemented a series of best management practices. In 2010, we started looking at the program again, and in 2019, put forward and it was finally passed a new approach, which is focused actually on looking at the actual data in the lakes, in 205 lakes monitored since 2001. To see if there were any problems, and if there were problems, implement a planning approach to them. And these were causation studies. Basically, if you had a documented algal bloom of cyanobacteria, if your phosphorus is greater than 20 micrograms per liter, or if there's an increasing phosphorus trend in the lake, you would stop and have a detailed examination of the lake and see what the problem was. And if the problem was caused by shoreline development, then of course, you would put some development controls on. This is an approach which I adapted from actually diamond mining projects in the Northwest Territories in the adaptive management plans that came from there. We also have to realize, and we've since realized that since 2019, we are having algal blooms all over the place in Ontario. MOE scientists have documented this. They're occurring in lakes where there's no human development, and they're occurring in lakes with very low phosphorus concentrations. And the causation is not certain there, but there's almost certainly a climate signal happening there with our changing climate. So Muskoka has had to adapt their approach as the years have gone by. We also have to recognize that water quality may not even be the most sensitive limiting factor on a lake. Here's 17 lakes from that previous slide I put up showing the approach. The black bar is how many cottages are on these 17 lakes right now, somewhere under 1,000. If we model up to an objective of background plus 50%, we can have over 3,000 cottages where there's presently about 800. It turns out, though, that if you take a 200-foot lot, a 65-meter lot, which is the planning standard in Muskoka, that there's really only room for about 1,100 cottage lots. So in this case, there's physically less space than the water quality tool would let you use. And if actually you accounted for the inaccuracy of the model, you could drive it up to over 10,000 cottages. So again, it's a false sense of security that you get managing phosphorus concentrations in lakes. So what? Well, you have to start asking the right questions. The Lakeshore Capacity approach is always asked, how much phosphorus is acceptable, which is another way of saying how green can my lake become, and translated into how many uses are acceptable. But is growth the question, or is it better management of the growth the question? What is the best way to approach shoreline management? Here's two examples of lakes that have lots and lots of capacity, but I would not advocate shoreline management practices on either one of these as being acceptable. On the left, we have a fully hardened gabion against a beautiful, lush, green, fertilized lawn running downhill from a septic system, and no shoreline vegetation, no wildlife habitat, and probably some pretty good scouring going along around those gabion baskets because they're concentrating the energy of the waves into the near shore. And then we have this other house, which admittedly seems to be under construction, but there's totally bare soil in front of it. And again, it's not looking like a good place, even if this would be allowed based on capacity. So there's more to it than capacity. So what do we do about that? We have to recognize that development does alter trophic status, no denying that. We have to recognize that there's variance and that the variance is much greater than the actual calculated capacity would be. We have to acknowledge where our assumptions are not supported and warranted. Maybe started looking more at lake sensitivity versus capacity when we're deciding how to manage it. Maybe we have to manage the nature of the development instead of the capacity, or maybe we have to look for other approaches as well, just as shoreline protection. Several years ago, my company did a review of lake management approaches for the Ministry of the Environment and looked across North America at different jurisdictions and found technical approaches based on classifying lakes, much as we are talking about doing sensitivity classification. We looked at the Caribou region in British Columbia, where they developed 3 rankings of water quality sensitivity, low, medium, and high, based on lake characteristics, which are listed here. And the more sensitive, the further back they set the septic systems. That was how they translated their sensitivity. The state of Minnesota looked at a lot of the same type of criteria and instead classified lakes by their uses. This lake is a natural environment lake. This lake is a recreational development lake. This lake is a general development lake, or this lake may deserve special protection. So based on the classification, based on the criteria they looked at, this would dictate the minimum development standards that would be done for each lake. The District of Muskoka, we talked about this before. We used the Lakeshore Capacity model to determine the capacity as background plus 50%. And then we classified how responsive the lake was if you added a set load of phosphorus here in the lower, and the mobility, the tendency if phosphorus actually moved from the septic system to the lake based on how accurate the model was. So a lake that was both highly responsive and where the phosphorus was reacting as predicted was a highly sensitive lake. Lakes that had low responsiveness and low or moderate mobility were considered low sensitivity, and then 2 classifications would be moderate sensitivity. And so these are the same 17 lakes we looked at before and how they fell out. And then you go over to the right, and as you increase the sensitivity of the lake, you start adding protective techniques. Vegetated buffers, we always recommend those. Shoreline naturalization, we always recommend those. Soil protection, don't strip the vegetation off the soil. As you go away from low to medium, you would start adding on-site specific stormwater controls as a condition of development, a limit to the amount of impervious surfaces that you would allow, trying to keep a nice soft environment to soak up rainwater, enhanced septic setbacks. On the high ones, you might even start looking for septic abatement technologies to manage the phosphorus in the septic tank. Again, this is assuming this is before Will Robertson's work was done to show the phosphorus is not mobile. Full servicing, site-specific soils investigation, enhance lot sizes, maybe limit the lot creation, maybe put a capacity in place, and maybe do some compliance monitoring and securities and increasing the monitoring intensity. So as lake sensitivity increased, you would increase the degree of management required to protect that lake. And one thing at the bottom, you see compliance, monitoring, and securities. I'll add that you can put all the rules you want in place, but if you're not prepared to enforce them, then they're not much good. So that was the sensitivity approach of Muskoka. Now here's another couple of interesting ones here in the northeastern USA. They often do individual lake management studies, which are triggered if there's poor water quality or algal blooms or large developments, but they don't do a capacity evaluation. Instead, they focused entirely on best management practices, such thing as less than 25% impervious surfaces, erosion and sediment control. And I get a particular kick out of New Hampshire. Here's their waterfront buffer guidelines. No development within 50 feet of the high water mark, no chemicals, pesticides, or herbicides, no rock or stump removal without consent, that would be from the municipality, no vegetation removal beyond footpath or to get a view or is approved, calculation of ground cover in segments. Now we hear a lot about libertarians in the United States, and I always get a kick that New Hampshire, which prides itself on its license plate and a state motto of saying live free or die, we hear a lot of that sentiment these days, but in this case, they're quite willing to accept government intervention to protect their water quality. So it just shows what you see is important. I always got a kick out of the New Hampshire license plate anyways, and seems to be a contrast with their lake management approach. So we're going to wrap up. Trophic status models are useful to scale or estimate lakes response. Modeled phosphorus concentrations of many variance elements. They don't support estimates of development capacity. We can use that to scale lake sensitivity, and we can use lake sensitivity to scale lot-specific management. And in the end, maybe we need to be adding more assessment and development controls to our official plan policies. But we do need a more comprehensive approach in Ontario. And this is where we have a provincial policy statement that kind of dictates the outcome for what we want to see in our lands and our waters. But it provides flexibility, the provincial policy statement, for municipalities to address that in locally specific fashion to meet their local needs. So we do need a more comprehensive approach. The lake capacity approach addressed one attribute by complex models that were increasingly uncertain. It doesn't recognize the variety of lake types, physical in the province, doesn't recognize that best management practices are increasingly effective and common, and that there's different planning regimes, different resources, and different abilities across Ontario, depending on the type of municipality. We've done whole lake management studies for Muskoka, for Sudbury. We've also done them for very small rural properties, for unorganized townships, where MOE looks at things. Everybody's got a different planning regime and a different level of effort. Muskoka's been able to push the envelope a bit because they've been monitoring their lakes for 30 years, highly effectively. So they've got a very good idea of what's going on in their lakes. And in the end, we have to remember what we're trying to manage. Are we trying to manage water quality, social crowding, local economy, a wilderness aesthetic, ecological attributes, or boating density and more active uses? And let's be honest about what we're really trying to manage, and not saying we just don't want any neighbors and we think we're going to pollute the lake otherwise. Let's be honest about what our factors are and identify what it takes to manage those and put the rules in place to do so. So we need to have management of various levels of planning organization. Unorganized areas are different than organized municipalities. We have to accommodate a range of geographic conditions and lake characteristics. We have a big province and 260,000 lakes. We have to understand the focus of our management policies and their supporting technical basis, make sure that we can support what we want to do. We want to apply within the context of our provincial policy statement and municipal official plans, and understand the resource requirements to do this effectively. So I think that's all. I'll thank you for that and leave you with my favorite watershed pioneer. I was paddled to the sea, who I read in grade 3 and stuck with me ever since. And he's just coming down Lake Huron, and we can see Halliburton over in the distance. So thank you very much, and back to you, Terry.
Okay, thank you, Neil. I appreciate your presentation. I think that it has created a lot of food for thought. And so what I want to do now is move to the Q&A section of the discussion tonight. And we're going to obviously have a virtual Q&A. We're not going to be focusing on people's, asking people to put on their camera or spotlight them like we've been spotlighting Neil or others. So I just want to remind you to put any comments or questions in the chat function. And what I'll do is try to curate those and pay attention to them and then put those to Neil and others. And when I talk about the others, we have, as I mentioned before, two key commenters, which we'd like to start with. The first of our commenters would be Jackie Hart, who has lived in Muskoka since 1900, enjoys walking through the forest and canoes and lakes and rivers. She's a 25-year veteran entrepreneur, the president of a business consulting firm called Consulting by Hart, and is the retired president of Water's Edge Landscaping in Bala. She's the first woman in Canada to hold the North American Green Industry Business Management Certification and is the current treasurer of the Friends of the Muskoka Watershed. I'm going to turn to Jackie in just a second. I'm also going to introduce at this time Jim Prince. He's the other key commenter, and he's been a regular visitor in Haliburton for the past 30 years, has owned a family cottage on Canisius Lake for the past 19. Jim is currently the Vice President and Stewardship Coordinator for the Canisius Lake Cottage Owners Association and was instrumental in developing and implementing that Lake Association's lake plan. So I want to welcome both of the key commentators, and I want to start with Jackie. Jackie, could you make a comment with respect to something that really struck in your mind about what Neil was saying, and perhaps then put a question to him?
Absolutely. Thank you for having me here. And I just want to, first of all, congratulate everyone who's here for being so passionate and committed to the legacy that you're leaving and that your community is going to leave on your lakes for the next generations that come. And I'll just start by saying I'm the third of 5 generations in my family of residents on the Muskoka Lakes. And when I was a young girl, we drank the water straight out of the lake without hesitating. The pump was in the boathouse, which was a shoreline boathouse. And the water came from the boathouse to the kitchen tap, into the glass and into your mouth. And sadly, within my lifetime, I have seen that privilege disappear from most of our lakes. And I think of my great nephew now as a young child, and what is the legacy that we are leaving for that generation to grow up and their children? And this is about stewardship, right? And you're all here because you're concerned about collective stewardship goals. And I just, Neil, I as a horticulturist and a career horticulturist, I think about the word phosphorus very carefully. And I think about plant material and plants and what they can do for filtering phosphorus and gobbling up phosphorus before it gets into the water. Many of you are familiar with fertilizers that you might buy for your houseplants or for your containers of annuals, or for even using bone meal. And it has a 3-number formula of nitrogen, phosphorus, potassium, NPK. And it's that middle number that is what we use to help plants with using bone meal, for example, which is 2,11,0, to help plants when they're transplanted to develop new roots. It's what's used for supporting blossom and bloom, especially in fruit producing plants. So phosphorus plays a very important role. And when I look at my landscaping history in the Muskoka Lakes, it was always about developing native plantings along shorelines in the first 20 to 30 feet in from the shoreline, using plants that would bloom and produce fruit, because they typically had more of a surface rooting. They typically would, native plants will establish quickly and on the shallow soils that we have. And it's the ability of that plant material to buffer erosion and also to buffer the phosphorus that's reaching the lake. But I think the issues here, Neil, go beyond the phosphorus question, and they really go beyond the permitted use versus the capacity. And as you mentioned in the introduction, I think it was Susan or Terry mentioned about Airbnb and VRBO, and how those many landowners on our lakes have started to use their cottages as a return on investment and as an opportunity to at least cover their expenses. And some have bought just for the purpose of rentals and just to, reap the benefit of the income. And I really, when I look at the possible solutions, I think about whether or not, Neil, this will be my question to you. Can you envision some solutions going forward of being a hybrid of lake capacity and the calculations that are involved with lake capacity along with permitted use? So, for example, if someone is going to rent a cottage, if the cottage is going to be used for anything other than immediate family, if the cottage is going to bring income from rental, then there may be a higher tax base. There may be a higher requirement and restriction with respect to how much open space there can be along a shoreline. There may be a horsepower limitation per 100 feet of shoreline for each cottage resident. So instead of having a boathouse or docks with a donzi and a ski boat and a bunch of jet skis, maybe there's a limit to potentially to the amount of number of horsepower per property or per cottage. And maybe there's an opportunity to get a little bit more specific about reforestation and preventing cutting of trees and stumping and rock removal, which Neil, you alluded to in one of your slides there. Really, really important stuff. And yes, all the recommendations are always don't remove the overburden, make sure the native plants are left in place on the shoreline, don't remove trees, don't remove stumps. And I see so much development happen where that's just ignored. And most of the wealthier developers are saying, fine me, it's okay. But the fines aren't big enough to discourage that type of abuse of the natural shoreline buffer and vegetation control. So I think this has to be a hybrid between permitted use and capacity. Neil, what are your thoughts?
Well, you've covered a lot of topics there, Jackie. Certainly shoreline naturalization, coming back to your comments on native plants and the role of vegetation. Intact natural vegetation and intact natural soils are incredibly excellent buffers against nutrients moving into the lake, against erosion from high intensity storms that you're going to be seeing now with a changing climate, and are always advised. One of the comments, I showed that slide on the low, medium, and high sensitivity and the increasing management restrictions. One of the comments I've heard on that is, well, why wouldn't you do that on every lake? Just because every lake deserves a high level of protection. And I support that. And things like shoreline naturalization and stewardship initiatives are very, very important. And I think you can get a lot of people with those, but you can't get them all, as you've said, which calls into the role of the need for enforcement. Right. How do you enforce it? Make the fines higher. You suggested that.
Way higher.
Some of the things I don't think are quite workable, like horsepower limits. You can go down and buy a boat on a weekend and the township will never know. I got nothing against horsepower per se. Like I said, it's how it's managed. I'm a sailor and a kayaker, but it's not my thing. But if people drive a boat responsibly, I'm not that concerned about it. The increasing use and the whole question of a cottage on return on investment put my hackles up, because that's not why my family has a cottage north of Tamaga. It's got an outhouse and it's primitive. We drink the water from the lake too. It's not a return on investment. It's a place where the family goes. Right. And unfortunately, I think we see this world moving too much towards money, and we're certainly seeing that now. Mm-hmm. And I would think it's entirely reasonable for a municipality to cost correlate their mapping with Airbnb advertisements. And if a place is advertising for Airbnb, then they are a commercial enterprise and should be taxed as such and managed as such.
Right. Well, they should be zoned. There should be a zoning requirement if they're going to be using a property for commercial gain and income. And I like the property, the waterfront property owners. I'm a kayaker as well as you are, and I kayak our rivers everywhere. And the damage that I see on the shorelines, especially after the flooding that we had 2 years ago, where there was an absence of shoreline planting, the riverbed erosion is unbelievable. And it's like somebody came through with a giant saw and just cut straight along the shoreline and cut down about 20 feet. You've lost that whole riparian zone in the rivers. So I've seen so many ways in which that shoreline buffer planting recommended is great, but I think the regulations need to be structured in such a way that it's not an option.
So a bunch of things there that we're going to need to unpack, and maybe we can do that through the chat box and people asking additional questions. But I'm going to move on now to Jim and get him to make his first comment and to pose the first question arising out of Neil's presentation. Jim?
Yes, good evening, everybody, and thanks, Environment Halliburton, for putting on this event. And thanks, Neil, for your great talk. I appreciated the way you framed the question, what are we trying to manage? Because we are stuck in a water quality paradigm right now in Halliburton. There's no question that is top priority, and most of the efforts we're looking at are focused on water quality. So refreshing to hear that another approach is likely the way to go. We're not sure how easy it would be to convince our municipal governments to shift right now, but that's a job for us. In your suggestion and wise words around the tools to use with our community and governments are also very welcome. So some good suggestions for us. In terms of a question, in our community on Genesis Lake and the other lakes, water quality has been a moving target, typically very slowly degrading. That's the signal we're getting. Total phosphorus is the biggest signal. Some clarity, but mostly total phosphorus. Those efforts to improve our water quality have been recognized for quite a while as a priority, and they're really gathering momentum right now in some communities. We are now convincing our local municipalities to put in mandatory septic inspection bylaws, some shoreline protection and restoration bylaws. Hard work, but it's taking place. And this is a bit of a hypothetical question. So imagine that sometime in the future that these efforts were wildly successful, and we did see lower total phosphorus, and we saw our lakes improving. And perhaps to Jackie's comments, they even magically put in bylaws restricting short-term rentals. So the municipality completely got on board with those of us who know that protecting our lakes are important. What would you say to a municipality where all these things were in place and things started to improve, and now they ask for more development?
Well, that's a very good question. That comes back to I remember years ago talking to the Federation of Ontario Cottages Association, and everybody was on about phosphorus. I said, what if somebody designed a septic system that took every gram of phosphorus and made sure it didn't get to the lake? Would you still have concerns? And they went, well, yeah, we would, but we've always managed them through, as you say, the sole focus on the water quality paradigm. And I think that is the problem. And I'll admit I'm as hollow visioned as most people, because all we're really doing is looking at phosphorus. And water clarity can change without phosphorus. We are seeing decreased water clarity in Muskoka, probably because dissolved organic carbon. These are the wetland tannic acids, humic acids, that give the water the orange-brown color. They seem to be increasing, and it seems to be related to a changing climate signal, changes in the wetlands and export from the forest soils. My wife used to dive on the Wyoming, a shipwreck in 90 feet of water in Lake Muskoka. In the 70s, she said she could see clearly down there. She tried it 20 years ago, and she says, I can scarcely see the hand in front of my face. So the water quality is changing. Calcium levels have been dropping in response to acid rain. Road salt is becoming a problem in some of our lakes, increasing a lot. So we have to look at more aspects of water quality, some of which aren't managed by shoreline development. And I think we really have to get very serious about climate change, because I think climate change, a lot of the symptoms of climate change are algal blooms, the same things we get with nutrient enrichment. And that is what we have to get serious about as a society to do that. And unfortunately, we as cottagers are probably, right at the cusp of the climate change, because we drive into big cars to our cottage and storm around in motorboats all day, and we have 2 homes. So it's we are part of the problem. But really, what if we did everything right and things started going? I guess, well, if you wanted more development and you could do it without impact, there's nothing wrong with that per se. But have you looked at everything, and are you accommodating all the different uses of a lake? Are you protecting the loon habitat? If you could achieve all that, then why wouldn't you? But the question is, how do you know if you're doing that?
Yeah. I think it does go back to your original framing. It's a lot more, it's more than just water quality. It's all about the other enjoyment aspects and loading, people loading, and all those things. So really good.
I would add, in terms of the enjoyment, that Seguin Township, which is just north of Muskoka on the edges of Parry Sound, they have another requirement that you can only have 1 cottage lot for every 4 acres, 1.6 hectares of lake surface. So they call that a social filter, and it just tends to overall keep the numbers down. The figure's totally arbitrary, like an 80-kilometer speed limit, like 50% above background, but it's been defended at the municipal board. They said, here is a planning rule we put in place. We're going to use social filters plus background plus 50. They've adopted a very protective stance, and it's been successfully defended at the municipal board.
Hey, thank you, Jim, for that question. I'm going to go to the chat line now, or to the chat box. And one of the first questions, it was a very quick question, but that photograph that you showed at the front end, where was that? That I think somebody wanted to know whether or not that was anywhere within Ontario or within shooting distance of Haliburton County.
No, I don't have a clue where it's from. Okay. I'm not even sure where I got it.
Okay.
I don't know. It might even be Photoshopped. I don't know.
Okay, perfect. Okay, so there was another question with respect to Robertson's work with respect to septic systems. And the question has to do with whether or not you could expand on this and speak to the question of whether or not these systems were fully functional. Were there any leaking or suffering from some kind of breakout? Was there any attention paid to the age of the systems and those sorts of things? So could you comment a little bit further on what Robertson's study was about?
Yeah, his final paper, the one from 1.5 years ago, actually looked at a variety of factors. The findings were robust in terms of how much hydraulic loading, which is the number of people contributed to a septic system, whether it's overloaded or not. So the loading function did not change his conclusions. Some of the septic systems, I know there's one over near Tweed, is approaching 35 or 40 years old, which is beyond the life of most septic systems, and it's still behaving as predicted. Some of his ones looked at, one of them was down at Long Point at the campsite on Lake Erie, and he found there that when the water table rises and floods out the upper zone of the septic system, it changes it from an oxygen environment to an anoxic environment, and the phosphorus starts moving again. And he documented that every spring, when the water table came up, the phosphorus would move, but the water table came down a week or two later, everything would lock up again. So he's looked at all these various factors. So yes, if your septic system is going to be flooded, that's going to invalidate those conclusions. But if you build according to the Ontario Building Code, your septic system will not flood. You're supposed to build it high enough that it will remain dry and oxidized. So my interpretation is if you build the code, you're fine. Septic inspections are another hard one. Back in the 60s and 70s, Ministry of Environment had a septic inspection program in Muskoka and Haliburton where they'd hire summer students to go out and look at lakes. They found on average 1 or 2% of septic systems were what you call failing. Breakouts, effluent on the surface, really spongy ground. That's not a very high number. Maybe 40% were considered fine. The other 40, 50% were kind of in between, maybe older than they should be, maybe more bedrooms than they were sized for, but there was no overt signs of failure. And to tell you the truth, you can't really tell if a septic system's failing until it breaks out. So none of Robertson's systems were, of course, that bad. They were all systems that were working as intended. But whether they would meet the criteria, I'd have to go back and check. But he is, in his papers, and I provided them to you, Terry, he does provide details of every one of his septic systems, its age, right, how many people it serves, et cetera.
Right. And what I've done is that we prepared a resource list, which we're going to send to everybody who's registered for tonight's event. And that resource list contains a reference to Robertson's paper and a way to get a hold of it. So it will be available to people, as will hopefully a copy of your presentation tonight too, being posted
I'll send that to you
onto
tomorrow.
the
Yeah.
Environment Halliburton website. So there's another question from Anton Davis about how background levels of phosphorus are determined.
Okay, well, there's really three methods. One is to be at the lake before any humans have been there and start measuring it for a couple of years and doing it by direct measurement. That would be the ideal method, but we can't do that. We've been up in this part of the world for 150 years. The lakes have presumably been altered. The second way is the example I showed from Peninsula Lake and Fairy Lake, and that is the paleolimnological method, where you can reconstruct the lake history based on what's preserved in the sediments. And that is also very effective. There's always a degree of error about it, but it has been proven as a great technique, and you can measure response to climate change and droughts in the prairies, phosphorus in the shield lakes, acid rain responses. All these have been documented and are well documented in the literature. And then the final way is to do the modeling that I described in detail, where you take the natural sources of phosphorus, atmosphere and the watershed, and you model them in the lake and see what the concentration is. And then you can add the human development assumptions and see how that changes. Again, there's errors associated with that, but that's really all we got. But the estimates of natural are pretty good. They're all come from monitored watersheds at Dorset, which have been monitored for 40 plus years, and they're updated periodically. That was one of the problems we found in 2010 when we reviewed the original Muskoka model, was because the ministry had updated some of the coefficients and we had better data, we'd been monitoring longer, had different comparisons. Lakes that had previously been at capacity were no longer at capacity, or lakes that previously didn't have capacity now had capacity, and people were going, but nothing's changed. And I'm the scientist. I said, well, look at the model inputs change. Of course, the output's going to change. And that caused a lot of tension, a lot of instability in people's responses, because nothing had changed, and yet the planning system was telling them that it had changed, and their lake was no longer the stable environment they thought it was. So there's pluses and minuses for every approach.
So Neil, there's another question in the chat box about at capacity in quotation marks and lake associations using that term to their members. I take it that has to do with the at capacity that's determined as a result of studies related to oxygen levels in cold water trout lakes. So could you just say a couple words about that process and what people mean by being at capacity as a result of oxygen levels in cold water trout lakes?
Certainly. First of all, those are the only lakes that are actually usually registered in official plans as at capacity are lake trout lakes that meet the criteria for capacity. Lakes are not generally classified on the basis of background plus 50%. The ministry just doesn't pursue that. But M&R are quite serious about lake trout habitat, and MOE are quite serious about working with them on it. How that works is, we probably all know that lakes stratify in the summertime. Down about 10 meters, 6 meters to 10 meters, you go through a layer, a thermocline, and then you're in very cold water at the bottom of the lake. That's cold, dense water that holds a lot of oxygen, and it doesn't mix with the surface until the gales in November come and mix up the whole lake again and bring oxygen back down. And lake trout have evolved to have very specific temperature and oxygen requirements, such that they stay in these deep cold waters all summer. And M&R scientists established that they need on average 7 parts per million of oxygen to thrive in those waters. So that's their criterion, is how much oxygen is in the hypolimnion in the deep cold waters at the end of the summer. Now, during the summer, of course, the algae are growing up in the surface waters where the sunlight shines and where the phosphorus are using the phosphorus that's available to grow. And we saw that more phosphorus generates more chlorophyll, more algae. As they die, they sink down into the bottom of the lake, and bacteria decompose the algae and use the oxygen. So MOE scientists and York University scientists have developed a model that predicts how the oxygen in the deep waters of the lake will respond to phosphorus additions. And so then you link that model, the phosphorus oxygen model, back to the Lakeshore Capacity model, and you say, okay, well, the lake right now has 7.5 ppms of oxygen in the bottom. If we add 32 cottages, that's going to drop it to 6.9. That's too much. But 28 cottages is okay. So that's how it works. It's just another extension of the phosphorus model that accommodates oxygen, and it's been calibrated for lakes in this area. So it's a really interesting tool, but it's again challenged by some of the same assumptions and uncertainties that the phosphorus model has. I hope that helps.
Okay, so there's another comment in the chat box having to do with horsepower, the comment that you made about horsepower and the fact that boats can be very damaging to shorelines and to wildlife habitat and so on and so forth. Is there anything that you came across that would be an effective control that municipalities could look at, or any other level of government for that matter, that actually would be effective in controlling the impact that watercraft have on habitat?
No. In short, several people in the past, I think very small lakes have been managed to arrange to be outboard free. But they are lakes where they never had outboards, and you have a United Cottage Association and a sympathetic municipality that have supported that. I simply don't see how a horsepower limit can be enforced. And unfortunately, I see this comment at the side. Yes, the wakes are incredibly damaging to things like loons. And now we're seeing things like wake boats, which are deliberately made to cast a large wake so people can surf on it. Another big problem. So unfortunately, this is the case where I think only education and sympathetic owners are all that can be done. And I'm not sure how much hope I hold for that. Horsepower in itself is not a problem. It's the displacement of the boat and the size of the wake and how it's operated. Many big lakes will have large waves in a windstorm, and the animals in the shoreline have adapted to that. But the problem is when you're generating bigger waves than that lake has evolved to, or you're doing it more frequently.
Jackie, you wanted to make a comment on that?
Yeah, my comment about horsepower was really to think about, how many motorboats should there be per 100 feet of shoreline? And if there was a limit, then cottage owners would have to consider, do we have 2 boats or do we have 1 boat? Can we have 3 boats or do we have 2 boats? And the lower the horsepower per boat, typically the less weight of the boat, the less draw. You're a kayaker, I'm a kayaker. We both know what it's like when you're paddling along and someone goes by and says, oh, I'm going to slow down for the kayak. They come down off of step and they leave more wake and more draw behind their boat than they realize they're doing. And all you have to do is watch what happens to the shoreline. Just sit in a kayak and let a motorboat go by and look at what's happening to how long those waves last for. So my comment about horsepower was whether or not it would, like a speed limit, potentially cap the number of boats and the size of boats.
Only if it was enforceable. FOCA in the 90s did a survey, and they said on average, most cottages had 7 boats of different kinds, not 2 or 3. You also see when I was a young man, 50 horsepower was a big boat.
Yes.
Now 50 horsepower is nothing, right? 300 horsepower is common. Boats get bigger and faster. And you can own the same cottage for several generations as your family has. And I'm sure the average horsepower of the boats that you purchase has gone up over that time. That's just a fact of life. It's available. People will buy it. The question is, can you manage that and can you control it?
There's another interesting sort of segue that I could just mention here is that in the European community, there is now a licensing process for internal combustion watercraft engines. That is to say that there is a cap now for climate reasons.
Mhm.
And we may see that actually coming down the road, depending on how seriously we take climate change and how seriously the government takes climate change, is that there may be, in fact, a licensing situation where we're going to try to reduce the number of internal combustion engines. I don't have any idea how that would impact, what the impact of let's say, electrical or battery operated motorcraft would have, and whether or not that would be any less in terms of the damage to wildlife habitat, for example. But I think from a climate perspective, we're likely going to see, a look at the European approach to a declining number of licenses available for internal combustion watercraft engines. So there was a comment in here that goes back to something you said with respect to septic system inspections, Neil, about the fact that we can't look inside them to see whether or not they're operating well or not. There is a level 4. One of the townships currently has a level 4 which inspection system. It's the one that the township that Jim is in, which is Dysart, although it's moving to a level 3. But the level 4 system requires lids up and a pump out at the same time as the septic system is inspected, and it's inspected on a routine basis, on a recurring basis. So I think the comment or the question is whether or not you think that those kinds of more intrusive types of septic system inspections, municipally sponsored, are a good thing.
Well, it's always good to make sure that your septic system is operating properly. It's there's many other dangers besides phosphorus. There's septic systems that are designed to treat the solids, to kill the bacteria, and to convert ammonia to nitrate. To remove the solids. So they can fail or be successful in many different aspects. A pump out, all a pump out does is remove the accumulated solids from the bottom of your septic tank that have accumulated. Generally, you should have it done every 4 or 5 years. If you don't do that, a high load will push the solids out into the drainage pipes and plug them up so the air can't get in, and then you stop functioning as you should. It won't do anything about the phosphorus load. The solids are a very small portion of the phosphorus load. They are about 10%. But it will make sure, inspection will make sure, generally when they look at my system, they look to see that the tank's not eroding, that the water's distributed to all the pipes, they're not sagging and putting all the effluent into 1 or 2 pipes instead of all 6. Those are all things that you can establish, but you need a good detailed inspection. And I'm not sure inspection is always a good thing. I'm not sure it would solve a capacity problem though. You have to assume that everybody's got a good septic system.
Okay, so there's another question with respect to the soil and its capacity to absorb phosphorus, and the specific reference is to iron-rich soils. So I think you made a comment related to this about the kinds of soils that we have in this neck of the woods being the type of soil that is capable of binding phosphorus. Can you just say a couple things about that?
Sure. There are, again, this is Dr. Robertson's research and actually people before him. There are 2 mechanisms involved. One is surface adsorption. That's where you have a charged particle on the soil that's attracted to the charge on the phosphorus. And so they just bind up. That is temporary and limiting. That's the phosphorus that comes off when you change the oxygen status, such as it gets flooded. It changes the valence state and phosphorus becomes soluble again when there's no oxygen. So that's a temporary, not the ideal mechanism. The other mechanism is mineralization, where the phosphorus reacts with iron or aluminum. Aluminum is the most abundant element in the Earth's crust. It's everywhere. Iron is close second. Phosphorus binds with these and becomes mineralized, forms actual crystals. And if you look at Dr. Robertson's paper, he has taken electron microscope pictures of those, and these are considered to be permanent, unsoluble minerals. And that's the mechanism that we rely on, and it's favored in aluminum and iron-rich soils on the shield that are slightly acidic.
So it's a good thing that there's lots of aluminum and iron in soils if you want the phosphorus to be bound and not be migrating toward your lake.
That's right. And you want to make sure that your system is not going to go anoxic. Yeah.
Okay. So there's another question from John Cowan about, is the government starting to classify lake sensitivity?
No, Provincial government, no, is still using the Lakeshore Capacity Assessment Handbook, which is the background plus 50 capacity approach. And I think you've made that document available on your reading list, Terry.
Yes.
That is not nobody's classifying lakes that way. Really, the only classification we have are on shield and off shield and inland lakes, which are anything but the Great Lakes. Those are the only real classification systems we have in the province. Other jurisdictions have looked at different means of classifying lakes. Then it might be a good approach to go to.
Okay, so I'm having another look at the chat function. I don't see any more questions that haven't already been asked. There's another one about rusty red sandy soil. I think that's the same question about the iron rich soils or aluminum rich soils binding phosphorus.
That's the upper horizon. When you dig through a profile, you will see the orange band, which is the iron.
Right. I guess there's a follow-up question that says, what type of soils are high in aluminum and in iron?
I think anything but silica sand. I think most of the native soils that you see in Muskoka are high. And I'm not a soil scientist. I'm just kind of remembering what I've read from Dr. Robertson's work and others. But you can see, if you look at a fine resolution geological map of this part of the world, you can see that there are glacial tills and moraines and shallow moraine deposits. If you drive up Highway 11, if you go off Highway 11, there's all kinds of gravel pits and sand pits, and those are glacial tills from when the glaciers melted. Those are the soils that would have the aluminum and iron would develop over time. You go further to the west towards Georgian Bay, and you have very thin soils and rocky outcrops with very little soils. There you would have to import the soils for your septic system if you're out in Georgian Bay, for example. So it's
and I think that
about soils.
And I think that Professor Robertson was talking about importing soils that are granite based, that have come from granite sources. Yeah. What about gray clay? Anything about you want to say about that in terms of its capacity to bind phosphorus?
I've never heard the term gray clay. There's two problems, or two factors to consider with clay. Clay does have a high surface charge on it, so it is very good it has a high affinity for binding things like phosphorus. But clay particles are very fine and they don't transmit water very well. So you don't build septic systems with a high clay content because the water will pond up and it won't percolate down like it's supposed to. So septic systems have to be built with a pretty good content of sand to allow the percolation and the oxygen infiltration to take place.
Okay. So one final question I just wanted to put myself before we end tonight, we're coming very close to the end of our time, was that the kinds of systems that you've been talking about all seem to me to involve a considerable level of investment at the municipal level and a lot of money put toward enforcement as to whatever we do. That is, if you're going to put rules in place, you better be prepared to enforce them or to make sure that that people are keeping to that speed limit, so to speak. The history recently in this province has been to cut resources that are coming along with downloading responsibilities, is to not make the resources available to municipalities to do those sorts of things, that robust kind of enforcement. And it seems to me that maybe just a comment from you with respect to that. If we're going to do a good job of having healthy lakes and healthy shorelines, we're going to need to invest more in the people that can help us get there.
Absolutely. And you need a good, solid planning department. I think much as the Ministry of the Environment, many people listening in, I'm sure our lake partners collect their spring sample of phosphorus that sends into the MOE labs, which is it's one of the best long-term databases available on 1,700 lakes. That's great. That doesn't cost much, and the provincial government still supports that. And it's a really good thing. So we have to make sure they continue to do that. In terms of responsibility, I think, almost downloading responsibility, you still have to follow the principle of provincial policy statement, but municipalities can interpret how they're going to do that. And you do need the resources for a good planning staff and to bring in experts as you need it. But a lot of the simple enforcement is not a big ticket item, right? You can hire somebody out of Sir Sanford Fleming for $50,000 a year, like a building inspector, and they can be your environmental inspector. And he or she can probably keep up with most of the requirements if they're willing to do that. So I don't think it's a big ticket item. And then I think we also have to look at what is the entry level for a cottage in Halliburton these days? $500,000. We're
Where were you
talking, we're
looking?
not talking about mom and pop $5,000 cottages anymore.
Right.
Sorry, Terry?
I was just saying, where are you looking? I want to know where the $500,000 cottages
Okay,
are.
I was trying not to let a Muskoka influence override. Entry level here is in the millions.
Okay.
So I think, you know, if people want to have a cottage in a good environment and they've invested hundreds of thousands of dollars in their cottage, then a little bit more, 1%, is probably going to do much better to ensure that the environment remains in good shape.
Okay. I don't see anything else in the chat. Oh, Jackie, do you want to put a final comment forward?
I was just going to add a little bit of humor and say, I think CRA has proven that managing behavior is very effective when you hit people in the wallet.
Okay.
So
unless they're really rich, Jackie.
well,
Hit them
yes.
harder.
Hit
Then
'em
the
harder.
fine would have to be proportionate.
If fines or taxation, property tax levies based on permitted use or uses, number of horsepower, number of boats, rentals, income, etc. There's all sorts of different ways of looking at it.
Okay, well, I want to thank Neil, you for your presentation, your great presentation, Jackie and Jim for your follow-up questions, and everybody who participated by putting their comments or questions in the chat line. I think we're going to have to call this portion of the gathering to an end, and I'm going to put things back to Susan for a final thank you and goodbye.
Okay. So I'd like to add my thanks, Neil, for your information-packed presentation. It occurred to me that the more you learn, the more you realize you don't know, and that was certainly the case for me. And thank you also to Jackie Hart and to Jim Prince for your part in our presentation, and to Terry for his role in getting this presentation organized, and to Eric for looking after the Zoom controls. And last but not least, to you, our participants, for joining us. And if you would like to watch this presentation over again sometime, or to share it with your friends, it will be posted on our website in the near future. We have another event coming up in just 10 days on Friday, March the 19th, which is the Global Strike for Future, inspired by Greta Thunberg. This event will be an analysis of the Federal Climate Action Plan by Terry Moore and David Robertson from the Education Committee of a new organization called Seniors for Climate Action Now. And I hope you'll join us for that presentation. You can go to our website to register for that soon, but it's not quite up yet. Hopefully tomorrow, Eric will have a chance to put that up. So again, thanks to all for participating. And if you liked what you saw tonight, please tell your friends about us. And again, thanks for watching and enjoy the rest of your evening. Good night. Thank you, everyone.
Thank you for being so well organized. That was great.
Oh, your presentation was just so packed with information, Neil. I was just amazed. So much.
Very good session. Thank you.
Yeah, thanks to everybody. This was great.
Thanks, Neil. Thanks,
Yeah.
Terry.
Okay, so take care, Jackie. Take care, Jim.
Eric, thank you for
Bye, everybody
managing
else.
this.
Take
Goodbye,
care.
everyone.
Night.
Bye-bye.